On June 1st, 2026, NVIDIA announced the Ultra model in the Nemotron 3 family. It is built as the flagship model for long-running agents. The headline is easy to misread. This is not a laptop drop-in for every local judge. Ultra is aimed at work where an agent has to plan across steps, call tools, keep context, and recover when the first attempt fails. The real question is placement. Where should Ultra sit in an engineering stack? And when is a leaner, more focused model the better tool? The timing matters. NVIDIA's announcement says the post-trained Ultra release is expected on June 4th. It arrives through model hubs, hosted builders, and cloud inference partners. The live docs page is different. It is the Ultra base page, and it describes a pre-training checkpoint, not a ready assistant. Base is the starting point for customization and post-training, so this video keeps the tracks separate. The announcement is about the ready agent model. The docs walkthrough explains the base checkpoint and the deployment path. Ultra is a 550 billion parameter mixture of experts model with up to 55 billion active parameters per token. That active count is why the model can be enormous without paying the full cost on every token. The docs describe a hybrid Mamba transformer architecture. Mamba is the sequence modeling side of the design. The transformer side carries the familiar attention machinery. Together they target million token workloads. That is the shape you would design for agentic work. It gives the model specialist capacity and routes each token through only part of that capacity. The long context layer stays useful while the agent reads documents and logs, then code and tool output. The model exists because long-running agents fail differently from chatbots. A chatbot can be useful in a single answer. An agent has to stay coherent across many turns, many tools, and many intermediate states. Coding agents need to understand a repository, plan edits, run checks, and revise when the checks fail. Research agents need to read a lot of source material and keep claims grounded. Operations agents need to connect symptoms across logs, tickets, metrics, and enterprise agents need all of that, plus rules about privacy, identity, and approval. Ultra is NVIDIA's answer to that heavier control loop. This distinction is the easiest place to make a bad video. The Ultra base docs say the base checkpoint has not gone through instruction tuning or post-training alignment. That means it is not meant to be used directly as a production assistant. It is valuable because it is the strong foundation you would customize. The announcement, by contrast, talks about a post-trained Ultra model for agent platforms and harnesses. When evaluating use cases, treat the base model as the training and customization artifact. Treat the post-trained model as the thing you would test inside real agent frameworks once it is available. Here is the filter I would use. Reach for Ultra when the work is long-running, tool-heavy, and expensive to get wrong. If the agent only has to summarize a short page, classify a ticket, or write one function from a tiny prompt, Ultra is probably wasteful. If the agent has to inspect a large code base, use multiple tools, interpret logs, and keep a plan alive through failures, the bigger model starts making sense. And if the task is visual, like reviewing rendered frames or screenshots, Ultra is not the first candidate. Keep a strong vision model in that slot. Coding agents are the cleanest first test because the loop is measurable. The agent reads an issue, maps the affected files, and makes a patch. Then it runs tests, reads failures, and tries again. That workflow rewards long context, planning discipline, and recovery after tool output contradicts the first guess. It also gives you concrete acceptance signals. Did the tests pass? And did the patch stay small? Did the agent explain the trade-offs? And did it avoid unrelated churn? Ultra should be tested on that loop before it is trusted on fuzzier business workflows. Research agents are the second obvious use case, but they need source discipline. Long context lets an agent read more, yet reading more does not automatically make the answer safer. A good research agent has to compare sources, preserve attribution, and say what is known versus inferred. Ultra is interesting here because the model shape is built for long documents and agentic workloads. The test is not whether it sounds fluent. The test is whether it can carry evidence through the whole chain without mixing claims together or inventing certainty where the sources are thin. Enterprise operations is where the announcement gets most concrete. NVIDIA names cybersecurity operational decision-making, and design simulation as early agent targets. It also points to manufacturing and healthcare coordination. These are not small chat tasks. They are environments where an agent reads many systems, proposes actions, and sometimes starts work that affects production. That is also why the surrounding runtime matters. NVIDIA OpenShell is the secure runtime layer for running agents with tighter controls. Policy and privacy are part of that layer. Identity and approval boundaries are part of the product surface. Ultra supplies intelligence, but the harness decides what that intelligence is allowed to do. Ultra does not erase the rest of the Nemotron 3 model stack. Nemotron 3 Nano is still the better shape for edge and local latency. Nemotron 3 Super is the practical local experiment target for DGX Spark class machines, especially when you want to test Nemotron behavior without renting a frontier scale endpoint. Vision models are still the right choice for screenshots, rendered frames, diagrams, and spatial judgment. Ultra belongs where the agent loop is long, tool-heavy, and text reasoning dominated. It should complement smaller local models and multimodal models, not flatten every job into one expensive choice. The model is the most visible part, but the production stack is bigger. The harness gives it planning, memory, tool calls, and retry behavior. The runtime scopes what the agent can touch. It decides what stays local and what requires approval. The evaluation layer measures real task completion. Confident traces are not enough. Ultra makes the model layer stronger. It does not remove the need for a harness and permission model. You still need observability and replayable tests. That is where production reliability lives. The walkthrough portion is deliberately built around the real pages. First, we open the announcement, because that is where the agent model, ecosystem integrations, and June 4th availability date live. Then, the Ultra base docs draw the line between base checkpoint and ready assistant. That page is the key split. Finally, we compare the deployment guide index, especially the Super on DGX Spark path, because that is the local deployment clue. The point is to make the docs clickable and inspectable, not to turn the video into a static summary. There are 4 risks to watch. First, availability. The post-trained model is scheduled, so local claims should stay conservative until the endpoints and weights are visible. Second, cost. Ultra is for high-value tasks, not every classification or rewrite. Third, evaluation. Agent traces need measured tasks, not just a fluent answer. Fourth, model fit. If the workload is visual, private, or latency critical, a different model may still be correct. Those limits decide whether Ultra is worth using. The takeaway is simple. Nemotron 3 Ultra is a serious candidate for serious agents. It is not a universal replacement for every local model, every visual workload, or every short prompt. The base checkpoint is for customization. The post-trained Ultra release is the one to test in agent harnesses once it is available. Start with coding loops first, then test research workflows and enterprise Those cases expose the difference between a model that answers well once and a model that can keep an agent on track through real